to follow the 3 bullet points that are shown here. I'm going to just take maybe 3 or 4 minutes to do a setup, but I'm going to purposely keep that short. And then I'm going to go into the discussion and engagement with Andy using real IHiS examples. Some of you will be familiar with, to some of you they'll be new and you wouldn't even have known IHiS has done this. And then we'll talk about some themes about the realities of everyday working with AI. Okay. Over the last 2 years, I've had this long journey, struggle, effort of being able to do this book with Tom Davenport. 29 actual case studies in a range of companies. 6 of the stories are from Singapore. Obviously, those were ones obviously I did. And it's not about gee whiz wow stuff. It's just what happens when AI is just your partner in doing the everyday work. And a look into that based on this set of examples. And then based on that, we pulled out what we call these insights chapters. All right. And let me just say something about Tom Davenport. Any of you have been working in analytics or knowledge management or process reengineering over the last few decades, you would have come across Tom's books and articles about these things. He's always interviewing CEOs, CTOs, CIOs, chief data officers, chief analytics officers, and he's incredibly prolific. For me, it was interesting because even at my stage of life, this was an opportunity to apprentice with a master. I had some background and I could bring some things to the table, but in doing this kind of project, Tom's just in a different league. And even at my age, obviously I'm older than most of you, if not all of you, the idea to learn by doing through teaming up with, in this case, another individual and teaming in a way where we did this project, I learned a lot. So I just, as a reminder, before we get into the topic that we're going to discuss, for all of you, learning in IHiS is not about the course catalog. I mean, there's a little bit of that, and there's a little bit of workshops. These things have their place and they make you aware of things. But learning is really learning by doing, and IHiS is a very rich environment to find partnering opportunities to do things with people who you can learn from. And if you're one of those like apex people who everyone learns from, and it's like you're already at the top of the pyramid in that level, the ability to come together with a team and do things that are beyond what you can do individually. How do we further take advantage of the IHiS environment for that? So much about this slide. I'm not going to go through these 29 case studies because that would be like a full hour in itself. But you see we did them, and it turned out retrospectively that they were in categories like sales and business development with Morgan Stanley, and the role of the Shopee product managers who had to develop AI products. And there we have actually 2 stories from DBS Bank and some of the interesting things they've done. Some of you will be familiar with medical coding because it might be part of the work that you've been involved in, and AI support for that. And the point of just showing you these categories of case studies that are amongst the 29 in the book. And here, we had about a dermatologist using AI-assisted skin imaging. I did up the story on Good Doctor technology and their use of telemedicine and the way they use it for triage, and the issues on porting Ping An's Good Doctor from China. Is that a lot of you are working on AI use cases, and it's not just the AI, it's the use case in the context of broader things. But since I've been through the experience of getting a feel for these 29, the ones Tom wrote as well as the ones I wrote, and then even after I finished the book project, I had to go make myself even, on top of that busy. And I worked with our national AI office out of the Smart Nation and Digital Government Office. And I did write-ups on 6 Singapore deployed AI applications that have a high degree of customer engagement in them because it's for some special international magazine on AI for customer engagement. And when I was doing that, it's like, well, gee, I'm going to help our Singapore Smart Nation office get even more good international publicity for their AI deployments. Why not do that for sort of my home organization, IHiS? And I got the editor to approve to do an extra article. And I teamed up with Andy and his people, and we're essentially done with that article. And over time, later on, we'll distribute it. And in that, we featured the story of Selena and its context, and the story of multiple readmissions and its context, and a little bit of command and control. So rather than tell you about the use cases in the book, I thought it would be more relevant to use the use cases that are within IHiS, because it's stuff you guys can all relate to. And then after we discuss this, we'll discuss some other issues about working with AI, part from our everyday IHiS experience and part from the book. All right, so much for my front end. So as promised, short. Now, here is our first example. This is Selena Plus together with SIDREP, is the Singapore Integrated Diabetic Retinopathy Screening Program. It's a national screening program. Andy, could you just tell us about the healthcare context of this application?
Sure. So basically, this applications takes in the uh, uh, renal images that's taken at the polyclinics into a central location, and basically we help patients identify three conditions. I think first one is diabetic retinopathy, age glaucoma, and also age-related macular degeneration. So then patients are sent off for referrals for follow-ups.
Okay, and this is a system of systems. There's a lot of parts to it because people go to the local screening station or wherever that is in their community. There's the teleophthalmology, a whole infrastructure that took years to build out. There's this way of coordinating the workflow within the ocular reading center that's been centralized for this national level screening. So everybody understands that the AI is just a component within a larger set of systems. But given that, how would you explain, Andy, the essence of what the AI module is doing? But don't use the term AI. Just explain it in plain English as to what it's doing.
Sure. So I think basically what we have done is, what the NUS and National Eye Center has done is created this algorithm where we took the rich data that we have collected over the last few years, train it using different algorithms and using things like GPU and techniques that were not possible previously to develop this tool to help use machine as the grader to look at all these eye images to determine whether or not they have these three conditions. So, yeah.
So the data in this case is an image. It's a visual image that's been trained using actually a combination of several type of deep learning methods, if I recall right, to identify cases where those three eye diseases are visible, and also many examples where they weren't visible. Correct?
That's right. So the accuracy of the model was as good as a human grader. So, and definitely better than what we call a level 1 grader that's less experienced.
Right. Now, we're always hearing from like the ministry and other outside parties, how do we put the health into health tech? Are there any aspects of the healthcare setting that influence the way the system is designed or the way they choose to run and operate the system?
Oh, definitely, Steve. So basically, if you compare these to normal industry practice, what happens is that when you determine a use case with a positive ROI, the model is developed and deployed, right? So we don't, I mean, we don't really care. I mean, as when I was outside in the financial industry, we don't really care if how accurate the model is or how much it will generate, but based on a certain calculation, we take the risk and we go. However, in healthcare, there's this thing called safety, right? And what we do is we have to not only do what we call retrospective validation, but we have to do things like parallel run. We call it prospective validation, where we run the model together with operations and then compare the results. We also do things like a blind test where we get human graders to grade the images, as well as the AI to do that. And then we identify any discrepancies so that it can be followed up. So this process takes quite a long time, and it is required not just on the safety side, but also for people like the patients as well as for clinicians to be comfortable with it.
So
It is,
one of
yeah,
your points there is even after the algorithm seems pretty good to the math and geek type data scientists based on the so-called training data they have, there's a very extensive validation process that sort of goes beyond what you'd get in most other commercial settings.
that's right. I mean, in addition, when we automate this, technically speaking, all scenarios can be taken on by the AI, right? It has been validated to be, as accurate as a human grader. But for considerations, taking care into safety and basic health, what we have done is, SNEC has done is that for all positive cases, it will be passed on to a human grader for verification, so that we can ensure two things, right? Number one, a safety net in case of any abnormal situations, and also the prevention of a waste of resource when we referred the patient who's a false positive and take up other capacity from the SOCs.
Yeah.
So yeah.
Go on. One of the things, Andy, is I was working with your team to do this write-up, and I read the original paper from 2020 from the sort of development team, not the IHiS team, but the team that sort of the eye science, if you will, and all that stuff. And they did this comparative cost analysis, and they used the base case of the new national screening program configuration where everything would move into the centralized grading center, and they had the level 1 and the level 2 trained graders. And then they compared that against two options for using the new AI system. One was the option of only using the AI system for level 1 grading. And the second option was using it for all automated, basically, no human. When they only used it for the level 1 grading, they still retained the human for level 2 grading. And the finding was that both of those options for using the AI system were more cost effective than the base case. But the way they chose to use the system was actually surprising. They chose not to automate both level 1 and level 2 grading, even though they could. And tell me if this is right, Andy, what I recall was that in this case, a false positive is very expensive, because if you have a false positive, you will refer the person to an ophthalmologist, right? So if the machine says positive, but it turns out to not really be positive because the machine has error rates, you generate one more visit to the ophthalmologist. And because of the inherent error rates in the system, it was less expensive to retain the second human expert grader, because it resulted in fewer spurious referrals to the very expensive ophthalmologist. I thought that was a fantastic example of putting the health into the health tech and choosing the concept of operations based sort of on health, economic, and operational considerations.
Yep, that's right. I think this is something that we definitely do a lot in healthcare. I mean, automation, maybe the sexy word for it, but we do a few evaluations to compare what are the best possible decisions to take on using data, so that we can get the best while making sure that we also gain the benefits from our implementation.
Andy, before we go to the second example, you've been working with this project for a few years, and my understanding now, it is actually live at very large scale, being used in all 23 of the polyclinics across Singapore, as well as other sites. So this one has gone full national deployment, right? What's your favorite part about this project? Just something that you feel especially proud of, or just privately is sort of like a neat thing to you about this overall effort?
There are many parts to this, but I think the most my favorite part would be, while the model was developed by NUS and SNEC, we were to help in the implementation. What happens was that it was done through a third party that commercialized the product. But as a team, we actually work with them to help design the model into a component, as well as change the way we develop this from a typical IT system approach to where we have data pipelines and design the application, the model, so that they have the relevant means for logging, tracking, error reporting, and it feels good to be able to contribute to a Singapore product that can be sold overseas. Yeah.
And if I understand, Andy, this was the first time a AI system was approved as a medical device in Singapore to be used for a national screening program.
That's right. I think the HSA regulations started, I think, a few years ago, and this was the first one that was put on their table.
Yeah, and we don't know, because there's no way to know this for sure, but it may be one of the first machine learning system software as an approved federal
Clinical
regulatory,
device, yeah.
Medical device used for a national screening program worldwide, although there's no way to definitively know that.
Yep.
All right, so let's move on to another example. Sebastian had mentioned Andy had been involved in a write-up on a project that happens to be this one. And again, Andy, help us understand the healthcare context of this one.
Sure. So I think there's been rising costs, from healthcare. And I think a few years ago, we were asked to look at, what are the key drivers of cost, especially in the acute hospitals. Our team was able to analyze using different analytics techniques to identify a particular cohort of patients that we thought would be quite interesting. Basically, patients who are at a certain stage of their condition that would potentially would have admitted into hospital 3 or more times within a 12 months period, and that would consume a lot of healthcare resources and the bed space in the hospital. At the same time, through surveys, we also found out from them that if given a choice, they would prefer to recover from home instead of staying in the hospital. So MOH with the PHIs discussed that there's this opportunity for us to do two things. Number one, reduce the bed days for patients in the hospital, as well as reduce admission. So then that was when the hospital to home program was initiated. Yeah, so I'm quite proud to say that we were able to use data to help influence the ministry to trigger and design a program for this.
Andy, I'm not an expert in health informatics, but from my naive understanding, I know that researchers and hospitals around the world have done many efforts over the years to predict readmissions within the next 30 days. But this is unusual in that it's trying to predict not just one readmission, but multiple readmissions over what in this context is a long time, 12 months. And that seems like it's a new approach to this type of readmissions prediction.
Yeah, Prof. So this is something that, I guess only Singapore can do it, because I think from most hospitals' perspective, they take 30 days readmission as a form of a, warranty, right? And in most countries, hospitals are tracked and penalized if they have patients that comes in after within 30 days. So, but in the context of Singapore, I think we have quite good 30-day readmission rates. Not the best, but quite good. But I think our perspective is more about the population and taking care of them rather than trying to meet an indicator for a KPI for the hospital.
So, Andy, this one again is a system of systems. It draws from the National Electronic Health Records. Many types of data fields need to be considered. In plain English, what's the essence of what the AI module is doing in this overall system?
Yeah. So there are three parts to it in this AI model, and basically it's a collaboration between IHiS as well as the informatics, clinician informatics across the three clusters. So within it, we have a prediction model for patients who are at risk for three or more admissions in next 12 months, as well as a 30-day readmission, as well as patients who are high risk of mortality. Now, we use a combination of open knowledge as well as from our local clinician panels to develop these models. And we used NEHR data because they had data across all the hospitals where it clearly were able to identify patients who were admitted into one hospital and a few months or weeks later, they admitted into another one where the other hospital is not aware about. With this, we were able to link them up so that, the what we call the anchor hospital that was looking at them at the first time could actually try to address the whole issue with the patient in that visit instead of waiting for another one to happen.
Okay.
So we have also implemented in such a way that it's near real time, where every day the list of patients and their risk will be sent out at AM in the morning, so that the clinical care team can take this on for patients who were just admitted in the last 24 hours to perform clinical assessment and triaging so that they can start planning for their discharge with enrollment into these programs.
So to just hit a point about the nature of the model, I believe from actually going through and reading the paper you and your team did, there are like 1,000 variables or some large number that get considered, and they're all drawn from the NEHR. Like there's, you don't have to create special data from this.
Yeah, so from NEHR, we actually took the data from NEHR as well as created data features. And in total, it took about 1,000 variables to come up with this model.
Yeah. All right. Now, you just mentioned that you run this model like every morning, right? And within 24 hours, and that's a great segue to the topic. This one has some very strong ways in which the healthcare setting influence the way the model is designed and used above and beyond what you might think of if you're just sort of like a data scientist sitting in your office about, can I optimize the nature of the prediction? So you said they run the model within 24 hours. And so the rest of our audience can follow. When the newly admitted patient is becomes an inpatient, within their first 24 hours, this model is run. Now, Andy, I happen to know from a little bit of background, people come in, these type of people, they tend to stay 3, 5, 7, sometimes even 10 days. If you want to have the highest level prediction of multiple readmissions, common sense or intuition would lead you to think, well, run the model at the end of their current stay when all the current lab work and everything from their so-called index case, their current case is done. But you said, no, we're not doing it that way. We're running it right after they check in. So there must be a reason for that, Andy. Could you explain?
Yeah, so Prof, this is a very good point. So I think statistically, the model will have the strongest confidence and to be able to provide the highest accuracy with the latest information, especially for inpatient admission, so that we can actually provide a higher level prediction accuracy compared to if we were to do it, when they are not, we don't have their latest record. However, when we were trying to design how we can inject this AI model into the workflow of the hospitals, we understand that patients who are discharged are harder to be contacted, and we need some clinicians to do clinical assessment and health checks, as well as to schedule appointments and schedule follow-ups at home. So this will be very difficult to execute on the ground if the patient has left the hospital. So we decided to change our model a bit to adjust for this. Even though it's at a lower accuracy, it would actually provide the information to the clinicians at the right place at the right time. In addition, Prof, I just wanted to highlight that we further reduce accuracy because we actually take into account the capacity that the hospital can take on for this kind of patients. So instead of going more accurate with a lesser number of patients, we actually decided to reduce the accuracy to bring in more patients onto the table so that they can be assessed and brought onto the programs where possible.
So I'm going to just restate two things that you said because they're so important, and it's such a powerful example of bringing the health into health tech. Of course, I have the benefit of having gone through the experience of working with Andy's team to sort of do this write-up we just finished. So they made the decision to run the model as soon as possible because even if a person is identified for being an ideal candidate for this hospital to the home program, you still need to get their consent. And you need to engage with them to get them to agree to come into the program, which means talking to them, talking to their family, an extended circle. And let's say most of the time they'll agree to come in, then you need to prepare what will happen after their discharge. And they need to be prepped, and the family members need to be prepped. So the clinicians said the speed was more important to us because the nature of the engagement that we need to do is time intensive. And they basically said, we as humans, when I look at this workflow over onto the right side of the slide here, under that thing where it shows the funnel and it's patient assessment, the nurses and the clinicians were saying, we have the real-time data. We if there's a new lab test, we've got it in front of us. It's not in the model. The model does the preliminary filtering, and then we augment that with what we know from the real time, and then we get the combination of the speed, and even though it's outside the model, we consider through our professional judgment the most up-to-date data.
Yeah, that's right, Prof. So I think this is the part where where human and AI work together, and AI augment the human to trigger them to identify certain risks that they can actually take on to work with the patients to decide what's the best program or outcome that they can try to achieve with the patients.
It's a great example of the joint human AI as a team. And you also mentioned they purposely did not put the accuracy, predictive accuracy, as high as it could have been. In this case, the false negative turns out to be very expensive. A false negative is a person who you miss, right? So the higher the predictive accuracy, sort of the more narrow the filter, and you're sure, but there's other people who you don't consider. So they decided to cast a broader net, as you said, because they had the capacity for the community program to run it. And this way, they don't miss people, because missing people here is very expensive.
That's right, Prof. So in this perspective, you would say that the human is augmenting the AI.
Yeah, yes.
Yeah.
So it's different than saying, well, how do I just optimize the prediction versus how do I optimize from the clinician's point of view and the total readmissions point of view, the entire workflow. So what a great example.
Yeah, Prof, I
All
just
right.
want to also share that what actually moved me, especially from the health in the health tech perspective, is that through statistical collection of data and comparison, we do know for a fact that patients who are at medium risk will return the best yield for the investment. But our clinicians decided that yes, the information is good, but they still decided to work on those patients with the highest risk because they deem that these patients deserve and requires the most attention. So it's not always 1+1=2 in our healthcare, but it's also about how we care for our patients as a population.
Well, what you're saying, the analytics models are part of the policy choice, but there's other considerations that also have to be brought in.
That's right.
All right, great example. Now we're going to go to a third example. This is the one that the TV stations love because it's, so photogenic. It's the Command and Control Center at TTSH and National Healthcare Group. What's the context for this one, Andy? It seems that it's quite different from the two others that we just discussed.
Yeah. So in this case, hospital operations needs to be swift and timely so that they can ensure patients coming in and going out have a seamless and good experience. However, I think on the ground, manpower and resources are all over the place and they are not optimized. What ends up is that, patient staffs are always reactive to the situations. And sometimes some of them told me that it feels like they're working in a war zone, right? But even though with the best effort, to try to coordinate this prior to the C3, patients had to wait long time to get to their bed, and the overall experience was not good because there were resources available, just that it was not available to them because it was not coordinated and tracked well. So I think that's where we wanted Tan Tock Seng wanted to bring in C3 to tighten up and how to and maximize what the resources are available in Tan Tock Seng and optimize the resources to bring a better experience to our patients.
Now, Andy, sort of stating the obvious, just having the real-time visibility, forget any planning, forget any AI, forgetting any optimization, is helpful, right? Just having what people like to call visibility and real-time visibility on the tracking. So with this system, they have that, but they've gone beyond that. This system is not just an AI model, it's a whole family of AI models. Could you explain how the AI modules are part of this overall system?
Yeah, I think a lot of people will confuse C3 for a video wall of dashboards, right? I think that's not what it is, right?
Well, it is that, but it's more than that.
Yeah, so at the back end, while we track things that are not usually track things like the stock and flow of, the bed utilization as well as the flow of patients in ED, there are hourly predictions that helps identify potential alerts for higher than expected volumes, that can allow the operators to determine, how they can actually best handle by either, triggering for more resources or opening up more ED cubicles for people. So with a combination of these smart alerts and also SOPs, the system actually can do this on behalf of the human and allow for SOPs to be triggered down where the right people or the right resources can be triggered to address the situation.
So embedded in this are a series of forecasting models. They're prediction models, but in this case, they're forecasting bed usage or medical supply usage or other resource usage. So someone has look ahead visibility.
So the look ahead helps in helping define the thresholds, because based on certain accuracy, by right at 3 p.m. I would have there should be about 300 patients waiting for beds, but if let's say it's 400, that means something is wrong because on the average performance we will never hit more than 300. That immediately give rise to a situation where the team can really take action on before it gets worse. So that's the smarts behind C3. Now, in addition to choosing what is the best SOP, right? We have also built in simulation models to compare different solutions within the SOPs so that it can the AI and the data can help decide what can be the best option for the hospital to take in order to resolve the incident, right?
So,
So this is something that is done at the back end, automated without human intervention.
so what you just said is these, there's a series of AI modules to do um, forecasting of load in the specialist outpatient clinics, in the emergency and accident and emergency, et cetera. And you're saying those feed into a simulation.
That's right. So the moment it hits near a threshold, a trigger, then those simulations will happen so that when it's near the point that requires attention, an option will be available, and that's the most optimized option available.
From what I understand, the TTSH people are enormously proud of this and always emphasize how helpful it has been to them. That might suggest, Andy, it could be quite helpful at some of the other hospital groups as well. Are there plans to expand the usage of this?
Yeah, so happy to report that Woodlands will be coming on board. We are going to start work with them soon. NUHS is now evaluating and gathering requirements to see how potentially they can adopt the Tan Tock Seng approach. So we will have two big clusters using this. SingHealth, I guess they are looking around, but hopefully they will join us one day.
All right, all right. So here we are, Andy. We talked about Selena, and that was an example of a system for early stage detection, right? And the earlier you can find the diabetic retinopathy and other related diseases, and the earlier you can start to treat it, you can prevent. All right. And big success story, already deployed nationally. All right. But you must have other projects in the pipeline.
Yeah. So
That
yeah.
not necessarily an extension of Selena, but other projects to help with other aspects of early stage detection.
Yeah.
So, for example, on this slide, we show several.
So we have we have one that is, taking the diabetics patients' risk of kidney failure as an indicator, and we intend to actually put this as a part of a patient dashboards that is being shared on the ground together with the clinicians to help them plan for how they can actually manage it better. We have other things like the ischemic heart disease prediction, as well as chronic disease management prediction tools or assessment tools to help the GPs and the community clinics for their patient assessment. One of the things that we're also looking at is the risk of severe bone loss. And I think these are the few kind of things that is in the pipeline.
So the first three are different aspects of the nationwide support for early stage detection and management of chronic disease. And the fourth one is an example of another type of early stage detection, but a highly specialized one, not in the list of the sort of typical chronic diseases.
Yeah, that's right. I mean, these are just a few of the examples. We have a lot more fun and strange use cases, but I thought I won't share it here because some of them are like a bit strange. Yeah, like we look at fungi growth, things like that. Yeah.
All right, but these are in the pipeline, and so for our audience, in the pipeline could mean in the later stages of larger scale field trials, or it could mean in the very earlier stages of just exploration, whatnot. But we purposely kept it vague of in the pipeline.
Yeah, for the first one, I think we should be able to see this go live probably in the next month in May, if I'm not wrong. So we can start to have patients who are visiting their clinicians, and when they pull up the NEHR, we will show a patient diabetic dashboard, and that is just a summarization of all the different indicators of that patient, and you will also have the risk indicator built inside there.
And the risk indicator is using what people would call one of these machine learning based predictive models.
Yes, that's right. So I think we built this AI model using the National Diabetes Database, which we built to collect all the cohorts of diabetic patients. And we use that to generate indicators and comparing different diabetic patients' journey to come up with the risk profile for kidney failure, which is probably, if I'm not wrong, a very prevalent disease condition for diabetic patients.
Now, in the first example we talked about in this category, Selena, in the context of the what people call SID-REP, that diabetic retinopathy screening program, a lot of the work happened in the 2010 to 2020 period with the very extensive and careful evaluations. And then finally, the scaling, actually just starting this year to full scale scaling. Is there anything new if you consider these pipeline projects for early stage detection? What are some of the new aspects of them that you find interesting? Whether it's a new aspect related to the analytics approach or a new aspect related to the way your team is going about it.
So I guess the new aspect is that we are now going towards more data from more devices. So we are using things like pictures from your mobile phone cameras, as well as other tools to help us gather more information to do certain detection of conditions. Previously, things that requires specialized equipment to do that, or human, we are trying to try new innovative ways through these other devices and IoTs to help gather the information to do some AI work.
Okay, so let's go to the next example. We talked about multiple readmissions and how that became a critical enabler for the hospital to home program, right? Because as I came to learn from working with Andy and his team, without that AI prediction model acting as a first stage filter, the nurses and other people in the ward would never have the time to do the sorting to go through and find these patients, because that in itself would almost take half of every day. So it's been a huge time saver. And if I believe right, Andy, this hospital, the readmissions prediction, is it used in every single public hospital in Singapore?
Yes, that's right.
So this is one that's used nationally across all three clusters in every public hospital.
That's right.
Well, that's an amazing success for national deployment. And thinking about what's in the pipeline for the family of systems that your group likes to refer to as targeting. What do we mean by targeting? Targeting for clinical treatments or targeting for inclusion in special kind of health support programs. So tell us about some of the pipeline examples for targeting based systems.
Yep. So I think we are moving into radiography images, the X-ray images, and one of the things we're looking at is mortality with commonly community acquired pneumonia. So this could help identify patients that are very high risk that requires ICU or additional additional attention, so that when they are in the hospital, we give them the best care to prevent that. Another one is to look at what we call unstructured data, where we go through all the case notes to identify adverse drug reactions to help in assisting decisions on medication callback recall in case of any admission risk. And we are looking at how can also help assist in determining the dosage titration, right, for some of the antibiotic Vasomany. And this is something that we want to help the clinician decide on the best combination and the best amount of dosage for each of patients. Today, there's a mathematical calculation, but we believe that different human beings have different kind of reactions to it, and some people may require more than others, even though they are the same age, etc., etc. So
Right.
this can help fine-tune that. Yeah.
So these are all deeply clinically oriented systems, which will require very careful multi-year testing and evaluation, I would imagine.
Yeah, that's right.
Okay. And The third system we looked at was really different because I mean, it's medical, it's in the hospital setting, but it's operations and resource management, right? And we talked about the one already deployed at scale, and you said some of the other hospital clusters are taking a very serious look at this. But you must have other projects in the pipeline for this type of system as well, resource optimization focused. Can you say something about the projects coming down the pipeline?
Yeah, so I think some of the things that we are looking at is to help predict the length of stay, so that we can have better optimization of the bed management for hospitals, and also the simulation of patient care end-to-end flows from A&E to all the way to community care, so that we can again try to overlay that to the hospital operations to identify where the synergies to optimize the entire experience for the patient at the same time from a resourcing standpoint.
Now, I just happen to know from my prior work at SMU as the computing school dean, all, I won't say all over the world, but in sort of well-developed countries, they've been doing things to simulate flows through A&E type wards, right? That's something that's very common when you go to medical informatics conferences. But trying to predict the flow into community care programs, that seems like really new and different, sort of one of these distinctively Singapore things.
Yeah, so I think this is something that we can't kind of copy from other people. So that's something that we want to be able to develop and create so that it can be applied to our own local context.
Right.
We also just to highlight that we also want to make sure that those people who are actually put into community care programs or even into nursing homes, we try to see if through this simulation prevent them from identifying the patients who will be sent back regularly, right?
Mm.
So I think these are the things that are actually happening on the ground that I thought is important that the team try to help to address. Yeah.
Yes, yes, yes. And you had that last bullet point about sort of social sensing across the world to get an early heads up if there's a pandemic heading Singapore's way.
Yeah. So this is something that if you look at all the social media and all the everything in the internet, first to determine what is health related is already not easy. Then secondly is to demystify the duplications as well as those that could be viral, that could be fake, or versus those that are viral that is really important. So that's something that we are playing around with. Yeah.
Okay. Now, underneath so many AI applications, and we saw this in the book, we actually have a chapter on platforms, and they're not the sexy part. But it's like the iceberg. It's the part that's under the water, the bulk and sort of gives the thing the heft. Could you explain what this brain platform is? The fun, clever acronym, Business Research and Analytics Insight Network. So we can obviously understand why you like the acronym. But what is it, and why is it important to the way your group does their work?
Okay. So firstly, I think my team and I has a point of view that we can only do good AI analytics work when we have all the data, right? And I think that is the number one challenge for most of the industries where they don't have enough data. But in our healthcare, we do have a lot of data, but they are all in disparate places. So one of the key things that Brain can do is to bring across all the data from all the different silo repositories, treat them, link them up, and anonymize them to make them available for all the users. I think that's the first part of why I think this is an important platform. The second part is that it allows for a multi-tenant approach, where we give individual projects teams their own private space to work together. So this will give confidence for more collaborations, and people from two different organizations can come together, share their data through this platform, work on topics that are important without having to worry about security, tools, as well as support. I think those are the things that this platform can provide. Now, in
In
addition, yeah, sorry.
go on,
Yeah.
Andy.
In addition, I think one of the only ways to apply AI is through rapid experimentations, where you try out different ideas, put them on to the workflows, and see how you can adjust and whether it makes sense. Previously, like the examples of H2H as well as through Selena. Uh, Brain allows this ML ops environment where people can quickly deploy and start trialing how they can transform their business, which is the key part. AI is not the important part, but it's about transforming the business to leverage on the AI tools, whether augment or as part of the automation, to maximize what they can do to achieve the outcomes that they target for. And that's something that you can do within Brain, because it has the connectivity to all the different other source systems and API servers to bring it to whether you want it to be on your mobile app or internet system.
Right. Now, something in health as well as in every other industry that's an issue is after a model is created and tested, moving it into the production environment and staging it at scale and deploying it. And there's often a big gap between those two worlds and those environments. Does Brain help with that transition?
So unfortunately, it does not. It makes the data science part a lot faster, but at the same time, it helps in a way where instead of what we did for hospital to home, where it took us 3 months to build the model, but about 1.5 years to convince the whole world by bring the information to share around with them. Brain allows you to really just deploy and then to see what's happening in real life, so that people have the opportunity to even start doing some sort of prospective validation or even blind testing, and that gets engagement and adoption going.
Right. Well, Andy, I can understand that, Brain can't address change management issues of getting, yet one more hospital to adopt. But I thought within Brain, it was partitioned such that there's both a development environment as well as a production execution environment, sort of all within the same tooling infrastructure and horizontal platform.
So it's within the platform, but it's two different environments. Actually, over the years, we have actually developed quite a lot of infrastructure and tool sets around these two different components. And actually, interesting that you brought this point up. And we are now relooking at further breaking up these two components to bring them further apart. We are trying to be able to reinvent Brain into something else, especially to support healthier SG, where the exploitation portion that is on the top of the diagram will be made more open and more flexible, so that we can actually accommodate more tools as well as cluster systems or cluster platforms. But the MLOps environment will still remain as a key component, because we believe that the amount of investment we put in to allow, I'll explain later. Sorry, Louis, hang on. The amount of investment and the effort put in to build up a ML ops environment is not something that everybody needs to invest on, and that could be a central capability that we can allow for concurrent experimentation, as well as even production deployment with the minimal effort from the business side. They then can focus on what's important, which is transforming their business, changing their workflows, or redesigning the way people use their services, so that they can really make a big difference in how either they serve their patients, provide care, or even detect conditions.
So you just gave some hints as to how Brain will be evolving in the near term and over the next few years.
Yep, you heard it fresh, first time in this place, right?
All right, yeah. Great for this seminar.
Yeah. Now to answer Louis' question, Louis has a question. I'll just quickly answer now. Health Data Grid is basically the data services where it is the obfuscation of how we bring all the different data from all the source system, treat them, and bring it out as anonymized data on the other end for our data scientists to use. So our data scientists will work on data that's anonymized. They don't really have to worry about where it comes from. But our source system owner are quite confident that this data are extracted, managed, clean, as well as treated correctly before data scientists can look at them. So that's where it is. We don't use that name much anymore, but we just commonly call it brain. It's part of the brain services, but basically it's the entire data service that powers the work for bringing data and cleaning data.
Okay, so now we're heading towards the latter part, and eventually we'll wrap up. So rather than talk about specific use cases in IHiS, let's come back to this theme of working with AI. And I'm going to pick up on some of the themes that Tom Davenport and I extracted from doing this sample of 29, and sort of ask Andy what he sees based on his visibility across the huge portfolio of projects DNA is doing within our whole public healthcare system. And one of the issues is this issue of fast and slow. So let me first deal with the slow part. In not all, but most of the 29 examples we looked at, we looked at them when they were all finished and successful. But for most of them, like DBS transaction surveillance and what Morgan Stanley did and Salesforce and whatnot, it took time. It didn't materialize quickly. And even with Agile, even with better tooling, right? These things can take, let me give two examples that you just gave, multiple admissions, prediction for multiple readmissions. While the model per se was a 3-month development effort, it was nearly a 2-year effort to get it used across the user base. Is that so? Andy, you're muted. You're muted.
Sorry, yeah, that's right.
Yeah, and in fact, Selena was longer than a 10-year journey, but a lot of things were going on with the build out of the whole tele-ophthalmology effort. But without that, you couldn't get the data to do the new generation of machine learning. So those two, one was a roughly 2-year, one was roughly a 10-year cycle time. What do you see, Andy? Are there some examples where these systems can come in quickly, or usually things are counted in terms of multiples of years?
So I think this is I would think more of a healthcare thing, right? Where people are generally very cautious. Where I was working with in the finance sector and consulting, as long as there's ROI, I guess the environment was not as worrisome as healthcare. People were willing to test and deploy it out, right? But as we go along, in healthcare, I see that there are two patterns here, right? There are some things that probably towards optimization and resource management. I think people are getting more and more open to adopting AI, right? Because ultimately, if you don't adopt AI, some of the products you use come with the AI anyway. So basically, you don't really have much of a choice. But because it's something that that the AI can solve, that is not easily addressed or solvable by a human being, the risk and the return differences are actually very, very much different, right? I don't take any loss if I miss another phone call where I don't have enough people in the help desk taking the call. But if I have a chatbot, even if they don't really provide human-like sentences, the risk is acceptable. I still get to connect my customers. I can actually get the information in and really solve some of their problems and improve the engagement with the customers. So those areas, I think we would generally see faster adoption. I cross my fingers because healthcare is very conservative, right? But in the areas of detection, I think there's a lot of potential, right? If we want to do things better, faster, I think things like Selena, things like what we're talking about in detecting the bone issue. These are areas where if we can do it consistently, accurately as a human, we don't really have to rely on human beings because um, their experience are analog. There is no consistency. Sometimes if people are tired, if you're bringing a fresher face, but having a consistent AI can baseline the work that you do, and I see a lot of opportunities in augmentation in that area, where human and AI can work together to really do a far better job, than both parties doing it separately.
All right, we'll come to that theme in a moment. And I guess my observation is, yes, healthcare is complex. Yes, the testing, validation, employment, deployment cycles take a long time, but we've seen several examples, as we just reviewed, and of course there are others, of real success across the Singapore system. And there's a lot in the pipeline, which means these new examples will keep coming. So this is a good place to be for this kind of work. When we did our book, we focused on the people who were the frontline users of the AI systems. Now, of course, behind the scenes, there has to be the data science people and the data platform people, and they could either be internal or they can come from an external vendor. But one of the things that really struck Tom and I when we did the book was that it isn't just the user and the data science people who are playing big roles. The supervisor of the user, the people thinking of the work processes and the workflow and the concept of operations, the leads and the sponsors, the customers. They were not just involved, they were playing big roles and important roles in shaping how things went. In other words, to be involved with AI applications and deployment, it isn't just the data science people, right? That's what we were seeing. Is that what's happening from what you observe as well?
Yeah, Prof. So actually, the way I look at it is that uh, IHiS almost all different parts of IHiS will play a part in this AI implementation, right? I think using the Selena example, we couldn't do the job if we couldn't extract out the images from the ophthalmology service, right? We couldn't get the job done if we couldn't integrate it back to the system where the graders can see the results or being flown through for referrals. I think the integration, working on the workflows of our BAs, who are talking to our users, can potentially identify and help them craft the transformation change in their workflows to incorporate AI into it. So there's a lot of potential for everyone in IHiS to play a big part. I mean, one of the things Prof, I told you before, I think something is missing in the diagram is all the translator and all the program managers,
Right.
where
That's these cross-functional roles.
yeah,
Product and program managers are
yeah,
exactly those kind of people.
yeah.
Yeah.
So these people are the ones doing all the hard, dirty, ambiguous work, bringing all the different parties together, experimenting on different approaches to do this. I think we need that kind of people, and there are so many of them in IHiS that we need to leverage on to help us. Yeah.
Yeah. So the important thing is it isn't just the data science specialists who are key to these so-called machine intelligence and AI-enabled systems. It permeates and has impact on all of IHIS. All right, that's pretty cool. So this fast and slow thing, Andy, just sort of an observation I have. It seems that people who are close to the data science work need to realize the richness and multifacetedness and complexity of the healthcare environment and sort of appreciate the good aspects of why some of these deployment efforts move slowly, right? if we're a patient, we'd be sort of happy that these things were done very carefully and thoughtfully. And like Selena, a lot of the AI methods were worked out maybe 2014, 2015, 2016, 2017. But there's been this massive progress at the algorithm side, at the method side. And anybody who's close to the field and tries to follow some of those developments, it's just overwhelming with large language models, with what people call self-supervised learning. It's reinforcement learning. It's happening all over the multiple sub areas of AI. How do you create a world within DNA where you deal with both this slow aspect and the fast aspect? How do we give some of our lead data science people the ability to play with that leading edge, and at the same time everybody have the appreciation that these systems take years through deployment, and once you deploy them, you can't yank everything out and just put all new stuff in, because that's a big project in itself. So these are contrasting worlds. It's like a yin-yang dynamic tension that will never go away. How do you deal with it?
So I'll try to share with explanation to Alex as well. So basically, Brain is in H Cloud, and we are proud supporter of HDC, but there are limitations, right? I mean, the cost is there, right? There are a lot of securities. So we have put aside a budget where our guys can use cloud resources from all the commercial cloud environments, as well as we bought some gaming laptops, right, for their GPUs, not for gaming, right? So this is to allow for opportunities where our team, who, you're right, we develop models very fast, and then there's a long period of engagement and gestation, adjustment. But in between that, they can do a few things. They can try out new tools, right? And they love new tools, right? And we don't just let them sit around and play with the tools every day. But actually, we have this Blue Sky program where our data science team actually identifies ideas, whether it be a tech push or a business pool, start working on new POCs with our users. So example is like, I'm just going to share a bit here, but we were put in the lab where I think the team saw some of the lab technicians looking at the fungi in the fungi lab, right? And then they discuss about why don't they just take a few pictures of the fungi to see if potentially they can use AI to detect changes to the fungi,
right?
using the image. Yeah, even though it's not very high res, right? Currently they use, if I'm not wrong, microscopes and other tools to help them look at that, right? And because of the Blue Sky, they went to do it. So I mean, the tech lab person was crazy enough to take multiple photos for us. Our team was crazy enough to put it into the cloud to do some deep learning, and we did a transfer learning of the model internally, and then try out over at the lab, and you know what, we could do it. We can do it, and it was a very, very exciting finding for us, where we don't think anybody has thought about that yet. So these are some of the things that we do to keep our team interested, where they can explore either from a tool perspective or from a use case perspective, while waiting for the implementation to happen.
Right. So it's important. Yeah. What you're saying is you maintain this prototype effort going on that's very important for engaging the core data scientists. And then everybody in the team also has to appreciate how they have to support these large, often long cycle time deployments. But in Singapore, we get them deployed. They do get deployed. Okay. Yes. One of the things that we came across in our series of examples where companies held back to some extent, and there were some aspects where they wanted the human to do it versus the AI. So it says here what machines can't do yet. And I said, or can they? Because if you dig deep enough into the research, you'll find an example of an AI method that, under some very carefully controlled setting, uh, could do all of these things. But uh, our hospitals and our clinics and our community care and our agencies are not carefully controlled situations. They're very complex, dynamic. And I'm not going to go through all of them. People seeing the slides can see ways in which, because our book featured examples of augmentation, mostly things that the people felt that they needed to be doing. And I just wanted to use this to pick you in how do you think about it on how far to take the automation? There are a lot of things we could do with the AI. There are a lot of things we could do with some degree of machine intelligence based automation that you might choose not to do. Andy, you're on mute again.
Sorry.
Yeah.
So I think there are opportunities because AI may not solve a big problem, but they can solve many parts of the small problems that is part of a big problem. And that is where I think there's opportunities for all of us, especially on the tech savvy and the tech professionals, to identify those opportunities and put our foot down, right? Because
Do you have some examples where you could have built the model, or you did build the model to do it, but you said, wait, they're not ready for it yet, or let's sort of keep this one so that people are doing it?
Yes. So, Prof, for example, we could predict people at risk of being a diabetics in the next 3 to 7 years, right? But the clinicians tell us, so what? You can't do much, right?
Yeah.
Without telling me what is the root problem, I can't really cure them, or prevent that. So we took a step back, by not looking at a very big problem. Then we start looking at a small problem, like are they high risk of kidney failure, even for diabetics, right? What's their risk of no show for coming to the
Right.
SOCs? So these are small problems that we think we can stitch up at different use cases. But I thought we could even further break up from a user experience standpoint, where
Yeah.
especially with Healthier SG, where we want to use digital mediums to connect with them. How can we embed layers and layers of AI to make it motivating for them to be looking at their health, as well as to be smart enough to direct them to the right services? And these are through small little AIs, and not big AIs, where
But
AIs will not take center
what
stage.
you called small problems, it's not that they were small, it's that they were actionable.
Yes.
Yeah. All right. Um, just as we're wrapping up here, how has your thinking about augmentation versus automation changed? But before answering that, Andy, why don't you explain in your mind, in your context, what do you mean by augmentation? What's your sort of mental model of augmentation? And what's your mental model of automation?
Yeah. So in my mental model for automation is where the AI can fully take on the digestion of the information, uh, compare different results, and then make that decision. And this happens without any human intervention. Augmentation will be how uh, a human comes to play, whether is it at the start, in the middle, or the end of that workflow, to actually either take action or be able to contribute more information, so that the entire workflow can be improved by using human and AI to work together.
What do you see as the advantages of augmentation?
I think augmentation will be uh, in situations where we require a lot of experience that is not documented, right? And where there are situations where it's not easily identified, or it's not easy to determine without human being in the loop. So, for example, in the case where I think, like I said before, if we do the prediction for multiple readmission, and you know it, if standing in front of the doctor, there is a high-risk patient who requires a lot of effort to help versus a medium-risk patient who you can do very little and get a lot of outcome. In that case, from a clinical standpoint, the right thing to do is to work on the high-risk patient. But if you use statistics, computer will just tell you go and work on the medium risk.
Right.
So I think the empathy, the human touch portion needs to be there, as well as a normality where we design AI within a strict construct of parameters, right? If something else comes into that parameter that is unexpected, I think that is where the AI will totally be oblivious to. Like some of the models that we are doing, we actually had to revalidate during the COVID period to make sure that there are no noise or other conditions that affects it. I think these are some of things that AI cannot do.
All right, let me just wrap up here, and because I want to hand it back to Sebastian, but just a few closing comments. I'm going to just say them real quickly. But after Tom Davenport and I did this project over about a 2-year period, we see more augmentation going on than cases of full automation. Now, we just had this tiny sample of 29 examples, but all the other material I look at, like the MIT Work of the Future Task Force, made the same point. We see augmentation working very well. Granted, many AI projects don't make it to full production, and many AI projects don't fail, right? But we only looked at successful examples, but we found a lot of successful examples of augmentation. And we're seeing that also in Singapore's health system, as Andy explained. This point that the collaboration of humans and AI, it's not the future of work. It's not the future of work. It's actually work now. A lot of places are doing it. Now, many places are not doing it. And the people who are doing it it's a relatively smaller number and highly concentrated into certain kinds of firms, or in particular larger kinds of firms. But it's successful where it's being used, so it's obviously going to spread. And let me just say to the audience as we wrap up, all of the evidence, not just from our work, but I poured over the work of the MIT Work of the Future Task Force that went on for a 2.5-year period, and lots of other things I've looked at. There's no immediate or impending threat of large-scale job displacement due to AI, robotics, and advanced automation. There'll be some, but not to the extent that you'd get the impression from a lot of media articles. And in fact, in 11 of the 12 world's largest economies, they're struggling for labor. And as we know, Singapore, obviously not one of the world's 11 largest economies. That's very much the case because of our demographics as well. So that's it. We're done. Anyone who wants to follow up, you know how to find Andy. You know how to find me. Seb, back to you. Stop sharing.
Sebastian, you're on mute. You're on mute, Sebastian.
Sebastian, you're on mute.
I'm sorry. Okay, let's give both Prof. Steve Miller and Andy a round of applause.